Okay, in this video we're going to look at some more examples of solving logarithmic equations. So example 1e, we have log base 2 of x plus 3 equals log base 2 of 6 minus x equals 3. So once again, we can get our logarithms on one side of the equation. This time we can subtract log base 2 of 6 minus x from both sides. And we'll have log base 2 of x plus 3 minus log base 2 of 6 minus x equals this 3. And on the left, we're subtracting logarithms with like bases, so we can use the quotient property to condense them. So rewriting the left-hand side, we get log base 2 of the expression x plus 3 all over 6 minus x still equals 3. And now we have a single logarithm on the left and a number on the right. We can rewrite this in exponential form as 2 to the third power equals x plus 3 over 6 minus x. So x plus 3 over 6 minus x equals 2 to the third power. 2 to the third power is 8, so we have x plus 3 over 6 minus x equals 8. Multiplying both sides by 6 minus x to get rid of our fraction, we have x plus 3 equals 8 times the expression 6 minus x. So we can eliminate our fraction by multiplying both sides by the denominator. So copying that over, now we can distribute our 8 to both terms on the right. 8 times 6 is 48. 8 times x is negative 8x. So we have x plus 3 equals 48 minus 8x. So adding 8x to both sides and subtracting 3, we'll get 9x equals 45, which makes x equal 5. And if we check this, checking x equals 5 does in fact work. We get 8 here and we get 1 here. Log base 2 of 8 is 3. Log base 2 of 1 is 0. So we have 3 equals 0 plus 3, which is true. Or in other words, the graph of log base 2 of x plus 3 intersects the graph of log base 2 of 6 minus x plus 3 at x equals 5. All right, example 1f, we have 1 plus 2 times log base 4 of x plus 1 equals 2 times log base 2 of x. So first up, let's rewrite log base 4 of x plus 1 using the change of base rule. So log base 4 of x plus 1, we're going to write that as a base of 2, since this is the base that we have for on the right hand side. We could take the log base 2 of x and write that as a base of 4, but instead we're just going to take this log base 4 of x plus 1 and write it using the change of base rule for a log with a base of 2. So log base 4 of x plus 1 is log base 2 of x plus 1 over log base 2 of 4. So when we simplify this, log base 2 of 4 is 2. So we can evaluate log base 2 of 4, we get a 2. And now this expression here, this log base 4 of x plus 1, we can rewrite it as log base 2 of x plus 1 all over 2. So substituting log base 2 of x plus 1 all over 2 for this log base 4 of x plus 1, we get 1 plus 2 times that quantity equals 2 times log base 2 of x. The 2's, this 2 in the denominator and this 2 out in front of the parentheses, will cancel each other out. So we're left with 1 plus log base 2 of x plus 1 equals, we can use our power rule on the right and bring the 2 that's out in front of the log base 2 of x back into the exponent using our power rule. Now we can get our logarithms on one side by subtracting log base 2 of x plus 1 from both sides, and we'll have 1 equals log base 2 of x squared minus log base 2 of x plus 1. Condensing that, we can condense the right-hand side, log base 2 of x squared minus log base 2 of x plus 1, using our quotient rule. So we can rewrite it as log base 2 of x squared over x plus 1. Now we have a logarithmic expression equal to a number, so we can rewrite this in exponential form. We get 2 to the first power equals x squared over x plus 1, 2 to the first power being 2. And I don't want to deal with fractions any more than you do, so if we multiply both sides by x plus 1, it'll clear out our fraction. So 2 times x plus 1 gives us 2x plus 2 equals x squared. Let's get this all equal to 0 so we can solve this. X squared minus 2x minus 2 equals 0. Unfortunately, this is not factorable. We have to use the quadratic formula for x squared minus 2x minus 2 equals 0. When we use the quadratic formula, we get our values of x to be 1 plus or minus the square root of 3. So we have x equals 1 plus the square root of 3, and we have x equals 1 minus the square root of 3. So in terms of decimal approximations, 1 plus the square root of 3 is about 2.7321, and 1 minus the square root of 3 is about negative 0.7321. Now that creates an issue. This negative creates an issue here on the right-hand side, where if we do 2 times log base 2 of negative 0.7321, this negative 0.7321 is outside of the domain for this logarithmic function, so we can't include it. We have to discard it. However, the 1 plus the square root of 3, the 2.7321 approximation, is okay, because when we plug that in, we still get a positive expression in this one. We get a positive expression in this one. And as a matter of fact, if we graph 1 plus 2 times log base 4 of x plus 1, and we graph 2 log base 2 of x, we will see that the graphs intersect at about 2.7321, or as an more exact value, 1 plus the square root of 3. So our final answer, x is about 2.7321. An exact answer, again, is x equals 1 plus the square root of 3. All right, so that about does it for this video. Thanks for watching. I'll see you next time.